Every year, unexpected machine failures cost global industries over $50 billion in downtime. The problem isn't that machines fail, it's that we never see it coming. Vajra X1 changes that. Vajra uses two AI layers working simultaneously. So we are targeting the manufacturing and industrial automation sector, specifically CNC milling machines, the assembly lines and automated production equipments. These machines run 24/7. When one fails unexpectedly, you don't just lose that machine. You lose the entire downstream production line. And the thing is, the machine always gave us warning signals. We just weren't listening to them. So we built Vajra X1, a real-time predictive maintenance dashboard powered by two AI models working together. Let me walk you through the nine-step process of building the ML model. So first is first step is framing the problem that we already did. Second step, data gathering. We collected data from Kaggle. Then third step, we have data processing. We have processed the raw data. We have cleaned the syntax. Then we found zero null values. That means it's a good data. Then we did exploratory data analysis. Uh, here are three types of machines, and then we saw that the the amount of machines that are healthy are more than the machines that fail, and that shows the real data. Hence, which is exactly what happens in real factories. So we had a heavy class imbalance problem. To fix that, we used SMOT, synthetic minority vote sampling. Um, Then we benchmarked eight different algorithms: logistic regression, random forest, neural network MLP, XGBoost, Light GBM, and CatBoost. Light GBM emerged as the champion, 98% accuracy, 100% F score on the heat dissipation failure, which was the maximum among the data. It also got trained under very less amount of time, under 3 seconds. You can see Light GBM, and we have the comparison down. As you can see, the accuracy of random forest and Light GBM are equal, although the training time of for Light GBM is so less that it can be implemented anywhere, and as it is light, it can be used in machines like Linux or Raspberry Pi, and the MCC score of Light GBM was greater than the random forest. So that is also a reason that we used Light GBM. Now let's get back to the demo. This is Vajra AI, a dual layer real time AI. So let me show you what that actually means. So Vajra X1 uses two AI layers working simultaneously. Think of it as, so first is LOF. So think of it as a dimmer switch. It um, the moment the sensors drift even slightly from the healthy behavior, this risk score begins to climb, giving us an early warning minutes before a failure. Then we have Light GBM. So this is like a light switch, 0 or 1. It fires only when it recognizes a known failure pattern from our 98% accuracy champion model. So when it fires, the risk instantly goes up to 100%. So, so together we have formulated a risk score formula. So it takes 65% of LOF and 35% of LGBM, Light GBM. So, and when Light GBM hits 100%, that means the machine has definitely failed. It overrides the risk score and gives 100% or 99%. Let's let's have a live simulation with overstrain. We had divided the same CSV file into different failure modes. You have overstrain, heat dissipation, power failure, tool wear failure. So let's run the simulation for overstrain failure. We have the signal breakdown here. This tab shows exactly what Light GPM is thinking at every tick. Look at the horizontal bar chart. And on the live dashboard, we have everything. We have the risk score, mechanical load, the thermal profile, rotational speed, and this is our risk score, which is 40%. It will gradually go up to 100% because it will fail eventually. But the model doesn't know if it fails or not. So yeah, you see the mechanical load, the tool wear has increased, and hence we had critical failure here. IGBM shows 100%, and we can validate the data in real time as well. These are the live phi precision values. So precision is 95%, recall is 100%, F1 97, and we don't just predict if the machine has failed or not, we also predict the root cause of it, OSF. The model didn't know if it was OSF or not, we knew it. So the the model predicted OSF. Vajra X1 doesn't just visualize failures, it notifies people. Engineers can input their Gmail or plus a 16 character app password here. At the moment, the system enters critical and email fires automatically with a risk chart attachment and a full CSV report. Uh, so you can see here, I got the email with the risk score and failure mode as well as the risk chart. So you can validate if the model has failed or not. Now, in the end, we have alert history. Every single transition from normal to warning, from warning to critical is logged here with timestamps, the triggering failure mode, and the exact risk score at the moment of transition. This is the audit trail an industrial client needs. Right now, Vajra AI runs on simulated sensor streams pulled from real industry dataset. But here's where we take this next. Package Vajra as a Docker container and deploy it directly onto a Raspberry Pi or industrial gateway sitting onto the factory floor. So predicting happens locally without sending any data to the cloud. We want to model the machines as a knowledge graph. So when machine A enters warning, the system automatically recalculates risks for all downstream machine it feeds onto. That is the real cascading failure prediction. But this is the basic model which we can use. And secondly, we want to connect Vajra X1 to a 3D digital twin of the factory floor. Instead of just a dashboard, the factory manager sees the 3D model, the components glowing red before they physically break. So Vajra X1 isn't just a prediction model, it's an early warning system that the manufacturing floor never had. Dual AI layers, real-time risk scoring, automated alerting, and a roadmap